All right. It is 11:30, and it's actually time to get started. So thank you for joining today's webinar entitled Flexible Distributed Energy Resources. Just wait for a couple of minutes. I can just start recording this because one of the participants asked to record this. So I'm going to record this.
Recording in progress.
And then the recording is going to be shared. Okay, so again, thank you very much for joining today's webinar entitled Flexible Distributed Energy Resources, presented by Professor Gharehpetian. So my name is Fazil Mohammadi, and I'm the chair of the IEEE Zeta Rho chapter at the University of New Haven, and I will be your event specialist for this session. All lines are currently on mute to prevent any kind of background noise that we may have. Please note that today's webinar is going to be recorded. We will have a Q&A session at the end of today's presentation, and I will be moderating that session as well. To submit a question, you can just simply use the chat box in the right-hand corner of your screen, type in your question, select host, and click send to get your question in the queue. And finally, if you experience any technical difficulties during this session, you can simply submit a chat to the host. At this time, I will give the floor to Professor Gharehpetian, and he will be presenting. So, Professor Gharehpetian, the floor is yours. So you need to unmute your microphone. Fortunately, we do not have your voice.
Okay, can you hear me?
Yes, right now I can hear you. Yes, yeah.
Okay, hello everybody. Thank you for the introduction. First of all, I would like to thank Dr. Mohammadi, IEEE chapter, and also New Haven University for inviting me to present this webinar. Would you please, Dr. Mohammadi, share my PowerPoint?
Yeah, just give me 1 second. Yeah, absolutely. Just please give me a second because it should be here. So I have this file. Just have to transfer this file to my computer. So I have to put it here, and then it's going to be done. Right. So let me make this page, and I have to go to here and download the file. Okay, so I have your file here. I'm going to go to the presentation mode, and then I'm going to share my screen and mute my microphone. So right now, I think everyone should be able to see.
Okay, I can see it. Okay.
So anytime if you want me to just switch to the next slide, please let me know.
Okay. Thank you. Thank you again. Okay. Again, hello everybody. As you can see, the title of my presentation is Flexible Distributed Energy Resources. My name is Gharehpetian. The name of my university is Amirkabir University of Technology from Tehran, Iran. Would you please, the next slide? Okay, I have divided my presentation in two parts. First off, I will introduce my university, myself, and my university. Then I will go to technical part. In the technical part, you can see in this slide, we have 5 sections. In the first section, I will present some current challenges of power system, and we will discuss about it, and we will discuss about a need for flexibility. But in section 2, we will discuss it as not only a word which can be found in a dictionary, So the concept will be presented from technical point of view in section 2. And then if we want to use and have a flexibility in power system, you can see we should know more about custom power devices known as COPS, which will be presented in section 3. At the end of this section, we can see that there is some idea about the possibility of integration of distributed energy resources using COPS. And then I will present some solution about it. And at the end, in the 5th section, I will draw the conclusion. I have tried to divide the conclusion in 2 parts. In the first part, the conclusion from technical point of view and about our presentation. And also in the second part of the conclusion, I will try to present some research topic. Also, I can say I have tried to have a webinar which can be useful for postgraduate students in order to understand the concept and use some ideas for their research. Next slide, please. Okay, as I said, I will start with an introduction about me. I'm coming from Iran. You can see the map of Iran in this slide. It is located on Asia, on West Asia. In this map, you can see in the north, we have the Russia. In the south, we have Persian Gulf and also Saudi Arabia. In the east side, Afghanistan, and on the west side, we have Iraq. So this is the general view about the geography of my country. The country is a 4-season country. Next slide, please. We have in our country a beautiful spring. In this slide, you can see the Mount Damawand. The height of this mount is 5,610 meters, the highest mountain of Iran, and there is a beautiful view. Please, next slide. Also, as I said, 4 seasons. Also, we have a summer and also hot summer. One of the hottest desert of the world you can find in the same time in Iran. This is the Lut Desert. Next slide, please. Also, fall is a very beautiful season of Iran. I'm presenting in this slide Shiraz, the city. Maybe you have heard about it. This is the fall of this city. Next slide. And also we have the winter, and you can see in a slide one of the resort. Its location is north of Tehran. Next slide. The capital city of the country is Tehran. You can see it's a mega city, about 10 million population of these cities. Next slide, please. And my university is also located in Tehran, in the center of this city. Next slide, please. The name of my university is Amirkabir University of Technology, also known as Tehran Polytechnic, and the motto of my university is Pioneer of Sustainable Development in Iran. Next slide, please. I would like to present some figures about my university. You can see we have about 7,000 undergraduate students. Graduate students are about 6,400, and the combination is interesting from technical. In a technical university, we have 35% female student and 65% male student, and you can see it's interesting. We have so many female students want to study engineering. In my university, we have more than 500 faculty members, including 500 full professors. We have 19 different departments and 24 research centers and institutes. Next slide, please. About the ranking of my university, I have used this slide. You can see we have a QS board university ranking system. It is an open website, and you can search for your university and you can find the rank of university. I have used this site. Next slide, please. The rank of my university using this website is 465, which is not so high, but interesting is this slide. Excuse me, previous one. Yeah. You can see in this ranking system, there is a different indexes, and they are using combination of these indexes in order to have a rank for a university. Between these indexes, our best result is based on the index of citation per faculty, which is 19 in the world, and it is very good rank considering from this point of view, and that is citation per faculty. Next slide, please. Okay, what about me? Again, I have used another open website, Google Scholar, well-known slide. Based on this Google slide, I can present my scientometrics data. Next slide, please. Based on Google Scholar, my H index is 733, and my papers have been cited more than 20,000 times, and I am among world's top 1% elite sightings according to ESI ranking system. Okay, in this slide, you can see my website, personal website, and also email, which can be used if you have, later, if you have a connection with me, you can use it. Next slide, please. Okay, that was the first part of my presentation, and I can go on with the technical part. In the technical part, in the section 1, I will start with a question. What are current challenges of power system? Next slide. Okay, in the current condition of power system, we can see that we have an increase in penetration level of renewable energy resources and also electrical vehicles. And what are the results of these two big changes? You can see we have renewable energy resources as solar farms and also wind farms, and these they are working on supply side. But their generation is not so determined and deterministic. So we can say we have a big uncertainty on generation. So the first challenge on supply side is uncertainty in power generation, which you can see in the as a first challenge in this slide. The second slide is based on, again, due to using renewable energy resources, but this time they are in the lower scales known as distributed generation units. Also, electrical vehicles will work and use in distribution system that is on demand side. So the second challenge will be known as uncertainty in energy availability, where on demand side. That was the first one. And the next one is the combination of these two, because now we have uncertainty in power generation and also uncertainty in generation availability. So as a power system planner, you should work with this uncertainty. As a result, the third challenge in power system is a need to change system planning method. The planning methods have been based on deterministic method or cannot be used now because they are so deterministic and they are trying to plan some plans for future. And in case of having uncertainty, the result will be not acceptable or will not work effective for us. And what about the fourth challenge? The fourth challenge is a need to change system operation approach, which is very difficult and important point for utility engineers. Utility engineers now have many problems with generation uncertainty, and also on demand side, we have many problems, or we will have more and more problems with vehicles. So this is the main problem of, we can say, the start is now, and in future we will have more problems with these four items. Next slide, please. Okay, considering this challenge, the grid needs flexibility. We need a power system in both sides, supply or demand side, which must be flexible. But the word flexible is not only a word which you can find its definition in dictionary. We should have a good concept and present it to you from technical point of view. Next slide, please. Okay, in section 2, we will discuss it. What does the flexibility mean? Next slide, please. First of all, we should focus on the word flexibility. Sorry. Please go to section 2. That's it. Okay. No, previous one. Yes, this is. Okay. First of all, we should focus on the first application of the word flexibility in power system. In power system, first, this word has been used in transmission system by IEEE Power Engineering Society Task Force, which they were working on the facts working group in 1988. So you see, the word has been used in 1988. But what is a FACTS? FACTS stands for Flexible AC Transmission System. In transmission system, we need some flexibility, and a FACTS controller is an electronic-based system that provides control on one or more AC transmission system parameters. But the question is, what is the transmission system parameters? Please, next slide. In order to respond this question, I have used this simple power system. You can see this power system has two buses, bus number 1 and bus number 2. Between these two buses, we have a reactance, and the power can be transmitted between these two buses. The power can be calculated. The power is P and is 1, 2. It can be calculated using this equation. This equation, the only equation I will use it in this presentation, because my focus is more on concepts and not the mathematical presentation. You can see in this equation, we have the voltage, also reactances, and the angle of buses. These three are transmission parameters, and a FACTS device can affect one or more of these parameters. So why we need this action? Because FACTS devices want to change the active power using manipulation of these three parameters. Next, please. And but that was the only definition used for the transmission system. But now this concept is not limited to transmission system. We can see that in 2011, IEA, International Energy Agency, presented a new definition for flexibility. You can see these two-line definition of flexibility. You can see in this slide. It says that the extent to which a power system can modify electricity production, consumption in response to variability expected or otherwise. I have tried to focus on keywords of this definition And we have in this definition 3 words in red in order to say that these 3 are the key words in this definition. You can see, first of all, flexibility has been presented as an ability. Ability for what? For modification. Modification of what? Production and consumption in response to variability, which can be extended or otherwise. That was the first definition presented by IEA. Next slide, please. Later, you can see in 2018, IEA again changed this definition and presented this definition. IEA said that the ability, what is the flexibility? The ability of a power system to reliably and cost effectively manage the variability and uncertainty of demand and supply across all relevant timescales. This interesting definition has important keywords. Again, keywords in red. You can see again, flexibility is an ability. And ability for what? This time again for management. Management of what? Uncertainty on both demand and supply side. And there is another point here in this definition. You can see at the end of this sentence, all relevant time scale with which we are working, we are considering flexibility as shown in this slide as an umbrella which can cover all needs of power system because we are working with demand side, supply side, and also all the relevant time scales. So it's so big definition and can cover all the needs of us. Next slide. Okay, again, you can see newly in 2022, again, IEA in its program, International Smart Grid Action Network, ISGAN, the working group presented again a new definition. Again, you can see in this slide this definition. Flexibility is the ability of power system operation, power system assets, loads, energy storage assets, and generators to change or modify their routine operation for a limited duration and responding to external service request signals without including unplanned disruptions. You can see the definition is much more in 4 lines, more details you can see here, but again, you can see the flexibility again can be seen as an ability, but this time for power system operation, assets, loads, energy storage system generator. Again, for what? Why we need this ability? Because we need it to change or modify the routine operation mode for a limited time, which is important to focus on this concept. And this is a very interesting and so general definition. Till now, we have this definition and we can work with it in all different combination and all apparatus or all parts of the system, power system. Next slide, please. Okay, again, in the report of IEA program in Annex 6, we can see an interesting suggestion about classification of the categories of flexibility needs, which I have used these categories and this classification for my presentation. You can see in this annex, we have 4 types of flexibility. Flexibility for power, flexibility for energy, flexibility for voltage, and also flexibility for transfer capacity. Next slide, please. Okay, then I can say if we want to affect flexibility from technical point of view and considering this concept presented in 4 categories, if you want to have this ability in order to affect flexibility, you should control active power, energy, voltage and transfer capacity, which is this is the important slide of my presentation. And I want to present the concept of flexibility based on this slide and definition. Next slide, please. In next slide, we have a question. Can we use distributed generation units and or energy storage system, that is distributed energy resources known as DERs, to affect flexibility? This is the important question which must be respond to it. But searching in the literature, you can see a possible solution has been presented in 2004 in a paper published in IEEE Transaction on Power Delivery. But now we have another question. Is there any general solution, not limited to one presented in this paper? Next slide, please. Okay, in order to have a answer to this question, we should understand the concept of custom power devices. We will use it later for our purpose, the purpose of this webinar. Next slide, please. First, I should say what are CPDs, custom power devices. These devices are tools to improve the power quality. But as you can see in this slide, power quality can be seen from two different points of view. One can be network point of view, and on another one can be customer point of view. Next slide, please. It is interesting to know from network point of view and from technical point of view, the customer are accused. They result in flicker, current imbalance, and nonlinear current waveforms. You can see from network point of view, all current problems coming from the customer side or demand side. As a result, the current problems of the customer must be solved. But what about another point of view? Next slide. From customer point of view, the network is accused. The network side has voltage sag, voltage swell, voltage imbalance, and voltage harmonics. You can see from customer point of view, the voltage problems are coming from the network side. As a result, the voltage problems of the network must be solved. But how? Next slide. Also, there are possible solutions to solve this problem. For example, passive filter using active filters. But here we want to focus on custom power devices, which should solve these problems. Next slide, please. You can see in this slide the first solution known as the STATCOM, distribution static compensator. On the right side of this slide, you can see the network, a simple network, including a load and also the utility side. In this slide, you can see the utility has been modeled by a generator, voltage source behind an impedance including RS and LS, connected to point of common coupling. And after point of common coupling, PCC, you can see we have a feeder which has been connected to loads. Also at PCC, we have the STATCOM. What is a STATCOM? You can see the combination of capacitor, a voltage source, converter, the true transformer connected to PCC, which can inject current, INVC, to PCC. Okay, in this case, the demand side problems, for example, flicker, current imbalance, and also current harmonics can be compensated by this STATCOM. How? we have problems on the load side, and the INDC can be injected in order to compensate for current problems of customer side. The next slide. Again, in this slide, we have the second custom power device known as dynamic voltage restorer, DVR. And again, on the in the right side of this slide, you can see the network, our grid, again, the same grid, but in this time, instead of having a transformer connected to PCC, this transformer is connected in series with line. And again, we have the capacitor and voltage source converter, which can boost the voltage. In the last slide, you can see we can inject current at PCC. In this case, we can boost the voltage in series in the line. Okay, in this case, the supply side problems, for example, voltage sag, voltage swell, voltage imbalance, and voltage harmonics can be compensated by DVR. And as a result, I can solve the problem of supply side using DVR. In the last slide, the problem of customer side can be solved by this StatCom. The next slide, please. Okay, it is possible to combine these two devices and have the third type of custom power devices known as Unified Power Quality Conditioner, UPQC. Again, you can see on the right side of this slide, on the right hand, you can see we have the combination of the last two one. In the same time, I can inject current, I and this C to bus, and in the same time, I can boost the voltage in series. Okay, the load side is obvious. There is problem with current, and also it is possible to have problems on the utility side. However, in this device, in this case at PCC, the supply and demand side problems can be compensated by this device, as I said, known as UPQC. Next slide. Okay. Now we want to use this concept, the important concept that in the all type of custom power devices, we can see we have a DC link, we have a DC bus. And the question is that, can we use this bus for a DG, distributed generation, or ESS, energy storage system connection? Is it possible to use this DC link in order to have a new connection or new player in this problem? Next slide. In order to respond to this question, in section 4, we will present the possible integration of DERs, distributed energy resources, using CUPs, using custom power devices. Next slide. Okay, again, the idea presented in the last section, in section 3. In this slide, you can see, again, we have a one voltage source converter. On the left side, you can see, again, we have a DC link, and the idea. What is the idea? It is possible to connect a DC energy storage system, such as battery, on this link and use it. And also on the right side of this slide, you can see, again, we have the same voltage source converter, the same DC link, and also it is possible to connect distributed generation resources which have a DC output and use them in this connection. Next slide, please. Okay, but what about the voltage source converter? We know that voltage source converters have two control variables. As a result, it's so well known in control theory. If you have two control variables, you can control two parameters. So One of the main parameters of our system in case of using a distributed generation units or for example, the DG units is generation of active power. As a result, I should use one of these control variables in order to have a control on active power. What about the second one? Okay, now the second one can be used, for example, for power quality improvement, which is the main goal of the COPS devices, or also it is possible to use it for reactive power control. Okay, we want to use this capability in our case. Next slide. Okay, the idea is that the result of integration of DERs using custom power devices is known as flexible distributed energy resources, the abbreviation FDER. Next slide, please. And I can now present the first solution known as FDR parallel solution to control the injected current. You know that you can see in this slide on the right hand side that you have the same grid which have been used for presentation of this STATCOM. But this time on DC link, you can see we have a DG source. I have connected the DG source on DC link, then I can inject active power here. The objective of DG, that is active power control, and also the second objective, which can be the objective of this STATCOM, can be achieved in this combination. Okay, that was the first solution known as flexible DER. Parallel solution. Next slide, please. In the next slide, I have tried to present a general view about its control system. For example, again, on the right hand side, you can see that we have again a DG source. For example, it can be a microturbine, and you know microturbine can generate active power at high frequency. Then I have a rectifier. I can rectify this power and have a DC bus on the capacitor, and after that I have an inverter. Using this inverter, through the transformer, I can inject the I and this C, which is the control or control variable. And using feedback in this system, I can have a control system in order to control the INDC and have the main and the second objective of using this device as parallel solution. Would you please the next slide? In this slide, you can see we have another solution known as FDR series solution to control injected voltage. Again, on the right side of this slide, you can see we have the same topology of DVR, but in this case, again, instead of using a capacitor, I'm using a DG source connected to the DC link in order to provide active power. In this case, the objective of DG, again, that is active power control, and the objective of DVR as the second objective can be achieved. Next slide, please. In this slide, you can see we have the combination of these two solutions known as FDR series parallel solution to control, in this case, injected voltage and current. In the parallel solution, we have the possibility to control the current. In the series case, we have the possibility of controlling the voltage. And in this case, we have the possibility of control the voltage and current simultaneously. And in this case, as I say, the objective of DG, that is active power control, and the objective of the UPQC can be achieved. Next slide, please. Okay, I want to have a short conclusion or result based on these slides. It can be said that we can use now these flexible DERs to control and affect power, energy, voltage, and transfer capacity. That is flexibility, which is important for us. From its concept is not is now so clear. I'm using these devices based on this combination in order to improve the flexibility of the system. Why can I do it? Because I can affect active power, energy, voltage, and transfer capacity. Next slide, please. Okay, but it's not so, it was only a concept. Now we want to find a framework in order to realize this, in order to realize the application or integration of flexible distributed energy resources. This framework, and the best one is microgrid, the concept of microgrid, which is based on the main concept of smart grid. If we have a microgrid, then we can have a control system, and based on this control system, we can manage, as it was mentioned on the definition of the flexibility, we can manage and control the customer side or supply side generation. Next slide, please. Okay, now I can draw the conclusion, and we can use the concepts again in this section and review them. Next slide, please. Okay, the first conclusion, flexibility is a necessity for a power system. Why? As I said, because we have uncertainty on supply side and also uncertainty on generation side. Why? Because we have the electrical vehicles and we are using them, and also we have the renewable energy resources also on supply side and also on demand side. On the demand side, known as distribution generation units, and on in larger scale, we have solar farms and wind farms. The second conclusion, excuse me, previous one. Yes, the second conclusion is this need will increase in the future, which is very important because we can see ever increasing use of electrical vehicles, ever increasing use of renewable energy resources. As a result, we have more and more uncertainty. As a result, we need the flexibility in future more and more. Next slide, please. The third conclusion is we need infrastructures to create more flexibility, which means from a local point of view, it is possible to discuss about flexible distributed energy resources, but its application and its usage is possible only if you have a suitable infrastructures for them. And this, as I said before in the previous slides, you can see the main infrastructure, and the best one is microgrids in order to use these flexible distributed energy resources. The fourth conclusion is DRs are an effective tool to improve system flexibility. Why? Because they can affect active power, they can affect energy, they can affect voltage, and also power power transfer capacity, and therefore they can change flexibility and improve it from technical point of view. In this case, I should say there is many interesting concepts, because if we want to improve something, then we should first of all know the current condition, and then what should I do in order to improve the current condition. Therefore, I would like to say I can draw the next conclusion in, please, next slide. Okay, in this slide, I can say I can present two important research topics. The first one, as I said before, we need criteria for quantifying flexibility, which means I should consider flexibility as a quantity. And for example, just now I have a power system. I should know its current condition, and after applying some manipulation on this system, the flexibility can be changed, and I should measure it. How? But then that's the new question for us. And just now I had a MS and a PhD student working on this subject, because there are different indexes and different combination of indexes in order to have a quantified flexibility concept. The second research topic is an interesting topic, focusing on the market. Because if we want to talk about the flexibility, we think that who can provide flexibility to us? We can divide it in three parts. We can provide flexibility as a distributed generation unit, or in general generation systems. Flexibility can be provided by the customer side. For example, we have many different demand side programs, for example, demand response programs. Also, it is possible to have flexibility using energy storage system. That I can say in the future, we need a market in order to bring these players together and have a possibility for using their capabilities as flexibility system providers, as generators, energy storage systems, and also prosumers on customer side. So a market framework must be designed for flexibility services. These two are important subjects which I can suggest to our postgraduate students and graduate students to study on it and focus on this subject in order to present interesting solution to us. Okay, that was my presentation, and I'm ready to respond to your questions. Thank you, Dr. Mohammadi.
All right. Thank you so much for your presentation. Right now, I'm going to start our Q&A session. So there are a couple of questions in the chat box. I'm going to go over and read everything. In case if you have any question, please simply use the chat box, type in your question, and I will try to read your question for our presenter. So flexibility.
As I said, the program of IEA in Annex 4, the classification was focused on 4 parameters. And in this case, as I said, we had or have voltage. So the voltage can be a presenter of reactive power for us. Therefore, it is enough to focus the voltage and not bring the power quality as a new classification part. It is enough to focus on voltage. If you want to have an index for quantification of flexibility, it was enough and have the concept of reactive power in it.
Okay, great. Second question is that, can we put the link of PowerPoint? Sorry, this is. does not mean to me. Maybe I can switch to the next question. Use of caps to get flexibility is expensive solution. Is that the case? But if DERs have controls within them, would not be a better solution. So would you please comment on this?
Yeah, it's a good comment because, as you say, custom power devices are expensive devices. And we are trying to use, for example, if the case is power quality improvement, we are trying to use, for example, passive filters, first of all, and then active filters. But in this case, we want to use the capabilities of COPS and in the same time distributed energy resources in one combination. And as a result, as I said, we have two options to control two parameters. And that's the only idea. The solution is expensive, but we are have a multifunction usage of them.
Very good. Another question, I'm not sure whether it's really relevant to this topic. Please discuss some cyber threat issues in operation of DERs.
Okay, it's an interesting question. Okay, as you know, the cyber attacks can be possible in different parts of the system. It's starting from its sensors, measuring units, control units, and also denial of service. So you can see in my combination, as I presented in my PowerPoint, you have all of them. So the question is so general, I can say it is possible to have the cyber attack problems on these devices, the same as the other ones.
Great. Another question, do fax devices such as UPFC, TSSC, TCSC, and etc. are different from COPS devices or they are the same?
They are different because they have different controlling objective function. I can say the COPS devices are the type, a form of, or I can say a group of fax devices which must be used in distribution system in order to improve power quality. But the fax devices, as you mentioned, like UPFC or the other devices, such as SVC, the StatCon, the ordinary StatCon system, we are using them because in order to control the active power. We are there, the object is control of active power, but the object of custom power devices are power quality, not the active power.
Great. Another question, can we use transactive energy for making our system more flexible?
Transactive energy must be considered in the, as I said, in the second research subject. First, we should have a market framework in order to have a possibility to use the flexibility service provider. And after that, it is possible to consider transactive energy in order to have flexibility. You see, first of all, we must have the framework, the market framework. And in this market framework, as you know, we have different solutions for transactive energy as a market system. And there is not so fixed one. So as a result, it is possible to have this in order to have flexibility, but it must be designed. It's only an idea.
Okay, great. Could you ask the presenter about the standards that we currently have as criteria for quantifying flexibility?
Standard?
Yes.
Unfortunately, we are working on indexes. First of all, indexes and then standard. So unfortunately, we didn't have any standard in this regard, but the researchers are working on standard on indexes in order, first of all, to quantify it, and then maybe in near future, for example, IEEE can work on it in order to have some standard for flexibility quantification.
Okay. Another question, do you consider hosting capacity in increases releasability? Or what is this? What is your suggestion? I'm not sure what releasability means. Maybe the question was asking about reliability, maybe.
Maybe.
So,
Okay, the problem of hosting capacity is, first of all, in case of having general distribution generation unit.
so
For
sorry to
example,
I'm so sorry to interrupt you. So the person who asked the question mentioned that he's asking about flexibility. It was not reliability. The question was about
the
flexibility.
connection between the hosting capacity and
Yes,
flexibility. That's
exactly,
the question.
exactly.
Okay, we have distribution generation units which can be renewable or non-renewable. So in case of direct connection of distribution generation units to the system, there are many problems considering hosting capacity. But in case of connecting the generation using the inverter-based system or converter-based, so general say, converter-based say system, it is possible to control the active or reactive power of their generation. Therefore, it is possible to improve the flexibility. But the problem is the hosting capacity. So the hosting capacity solutions can be the same. If you solve the hosting capacity problems, then you can have more distribution generation units, and therefore you can have more flexibility.
Great. So one of our participants asked about having some reference papers which act like basic for understanding CUPS or fax devices. So maybe we can provide those kind of references later on when we are just trying to, prepare the post-event package. So that question is going to be answered later on. So let's go to the next question. Regarding quantification of flexibility, what do you think is the main challenge? As you mentioned, some indices for quantification. What are some indices for flexibility quantification?
What are the challenges? For
Yes.
example, you consider a case using flexible distributed energy resources connected to a bus. And it is a bus in distribution system. And in this is distribution system, I have many buses. Each bus has a voltage. So if I want to quantify the flexibility effect of this device on voltage, how should I consider and quantify it? For example, one of them can be considered as, okay, I can consider the same index, for example, if as a I am using it for in objective functions. One minus voltage of buses for buses number one till the end, and the sum of these parameter can be considered as an index. But is it enough for us to consider flexibility? Another one can present another index. So which one is useful and which one has a more accurate concept? Because the flexibility is changing when the time changes. You see, if I have a flexibility at 8 o'clock, it is not the same the flexibility at 9 o'clock or 10 o'clock. You see, why? Because the system is so live, and the condition will be changed in each hour. So as a result, another question comes for me, and I can consider that, well, yeah, I have this index, but this index is for 8 o'clock, then later this index will be changed at 9 o'clock, and so on. So it can be a challenge for me. How can I calculate the flexibility of a system in a day? And the next question, what about the tomorrow? What about the week? What about month? What about year? How can I say a power system is flexible for this day, but tomorrow it is not flexible? How can compare it? And that's the many question about it. And I think our students can solve it in future and giving some suggestion about this question.
Great. So the next question is again about those indexes. So here, so our participant asked about, could you mention some papers? So maybe I think you already respond to this because you mentioned that you are still working on this
Yeah,
topic with students, and most probably there is no published work right now, maybe.
yeah. I would say it's better to search about it because it's so up-to-date topic, and maybe you can find so many papers on this subject, and the researchers trying to solve this problem.
So the next question, do we have any criteria for measuring how much our model is flexible against the change in production or demand?
No, I don't have this because it must be so interesting for me to have to find this type of model, because you first of all you should solve the problem of modeling the flexibility and presenting flexibility in a mathematical framework.
And also you mentioned this, that so today we have one model, so it's going to have one certain pattern in generation and demand, and also next day, next week, next month, everything is going to change, and therefore still we have to work on a generalized framework to just handle all these kind of things. Okay, great. So the next question, in flexibility, sorry, it seems that it should be written in flexible markets. Flexibility is a product or service?
I would say service,
Service.
because I'm considering the players as flexibility service provider. You see, they are present in providing a service to the system.
Also, if it's a production, so you answer to this question, so it's going to be on the service side, but just consider that if it was on the production side, can we use that one to improve the operation resiliency?
Oh, resiliency is something you know it's has a high impact, low probability, but flexibility is something live, which is can be considered in each hour, each day, each week. So I cannot consider this concept. I would say that I cannot see overlap in this concept.
See, I see. And another question, what is the difference between flexibility and feasibility?
Flexibility.
Feasibility.
Feasibility.
So
Oh,
yes.
yeah. Feasibility is something else. So you see, if I'm talking about the just now, I want to have for example, the service provider, flexibility service provider. I'm asking about the feasibility. But if I'm talking about flexibility, as I say, there is some definition for it presented by IEA, and it is fully something other. They are different, so different things.
Okay. So another question, what is the impact of having smart grid on the system flexibility?
Yeah, so interesting question, because you see, as I said, we need a framework. We need a framework in order to realize this concept and use this concept. And in the smart grid, as you know, we have so many sensors, measurement. Also, we have AMI, advanced metering infrastructure. And as a result, I can have a feedback from the system. And as a result, I can observably, and a system which is observable. So in case of have a observability, then I can react on the system problems or system condition. As a result, the smart grid can realize for me a framework, a good framework, in order to have microgrids with control system. And in general, I can realize the concept of flexibility, or I can realize also the market of flexibility service providers.
Okay, so another question, what are the requirements in a smart grid to improve the system flexibility?
Uh, as you know, the first one is the measurement system for a smart grid. You know, the measurement system, the same as the AMI. It must be advanced metering infrastructure. After that, we need communication infrastructure in order to communicate the measured data. And in the third level, we should have the dispatching center or control centers in order to use this data, in order to analyze this data and present some order functions or order signals and send signals again using the infrastructure. And in the fourth level, we should have actuators in order to apply our manipulation to the system. For example, distributed energy resources. They can be considered as actuators.
Okay. Can data-driven approach or artificial intelligence improve the flexibility of power grids?
Yes, yes, for sure. Because we need so many forecasts for example, as I said, one of the most important challenges of current power system is the uncertainty on demand and supply side. So, how can I solve the problem of uncertainty if I had a accurate prediction, for example, accurate prediction for load growth, then I can have a better planning system. So AI can improve this prediction and improve the accuracy of the system. It is so important to use them.
Great. Do you think quantifying flexibility can have much common approach to some methods which quantify inertia in the grid?
Oh, okay. You mean instead of flexibility, we are working on inertia.
Yes.
I see there is some, just now, we have some methods to estimate power system inertia at each instant. But inertia, I can say that in my classification, as I said, presented by IEA, it is based on power, energy, voltage, and power the capacity transfer capacity. But there is no place for inertia. I can say it is important to have a flexible system from technical point of view. If I have a estimation about the inertia, I can have a good operation condition, and the system operator can handle the system better. It is important. But from this point of view presented in my presentation, I didn't have any discussion about.
Okay. So this question again comes from our previous participants. So my question was that can flexibility be used to improve the system resiliency,
Oh,
especially in high penetration of renewable energy sources?
oh, as I said, the connection, there is no connection because its probability is so low and it's high. There is a high effect, but probability is so low. But flexibility is the problem of the hour, day, month.
Okay. So the next question, are these COPS devices suitable for long transmission systems?
No, in transmission system, we are using fax devices. For example, instead of UPQC, we have UPFC, Unified Power Flow Controller, instead of you having UPQC. Or instead of DVR, we have a 3SC, Static Series Compensator. So they are different.
How to avoid inertia issues when we are integrating renewable sources with power grids?
So only using the power converters and control system in the which in case of having a because if we have a inverter based distributed energy resources, it is possible to control its active or reactive power or can apply some changes considering inertia. But in other cases, the system have the natural inertia. For example, if you have a gas engine based distributed generation unit, it has its self inertia. But in other cases, it is possible to use the converters to improve it.
Okay, great. So I do not see any other questions, so we are going to wait for a couple of minutes to see if any new question would come up.
Mhm.
So far we have, I think, answered all questions. So just need to wait for a couple more minutes.
Okay. I hope the presentation was useful for the participant, and I don't know, there is it is possible to use it later as a saved file or for
Yes,
the.
I'm recording. I'm just doing the recording, and this file is going to be shared with all the people who have participated
Okay,
in this particular session.
that's
So, new question came up. So, in power grids, we are having less inertia issues compared to renewables, but we have more issues in renewable-based energy grids. How can we address this problem?
okay. It's so big problem, and
Yeah.
it can be answered only using a few sentences. As I said before, the concept is using converters. It is possible to have a control on the system, measure the inertia, and then react on it. You see, there are many questions about inertia, but the concept of this presentation was flexibility. And flexibility are working on active power, energy, voltage. And as I said, the inertia can be affected, but there is not in this classification. Maybe I should think about it and bring some solution about it using this concept of flexibility. But just now, in the definition of flexibility, I cannot see the concept of inertia.
So, are there same issues if we want to use EV batteries to supply power grids?
Yes. I think you can see the same problems because you have the same uncertainty using the power of these EVs, obviously.
Great. So, what is the main advantage once we replace capacitor with a DG, given that DGs or DERs have, variable nature and they are not reliable sources?
Oh, that's easy because you see, in our case, we want to have an active power injection in the system, and the capacitor connected on the DC link of voltage source converter doesn't have any enough energy in order to boost the system or receive it. It's working as a in order to have a constant voltage on it only. Then if I want to inject power to the system, so I should use distributed generation unit in order to receive. Or instead of it's possible to use energy storage system instead of capacitor in order inject or absorb active power using true voltage source converter.
Yes. So, I think this was the last question, and going to wait for one more minute to see what's going on. And to all our participants, in case if you got any other questions, you can just directly contact Professor Gharehpetian because his email address has been provided, and you can simply contact him and you can just ask your question directly, or you can submit your question to us, and we are going to just provide all these questions to him, and he's going to answer, and we are going to prepare our post-event package. So another question came up. As the renewable energy resources are intermittent in nature, how can we attain flexibility?
That's the main question. As I said, this
Yeah,
is the reason why we want to have the flexibility,
exactly.
because their nature is so. So we need it because in near future we will have more and more renewable energy resources, and that's the reason why we need it. We need the flexibility.
So, okay. Uh,
Okay.
Yes, I think we're done, and I want to again thank everybody for coming today, and I would like to thank our presenter, Professor Gharehpetian, for his presentation. So the recording and the slides related to this event will be shared with you within the next couple of days. And as a final note, since some of you may not be IEEE members, I would like to let you know that by being a member of IEEE, you can earn a scholarship and grants to help you to just get ahead in your education. You can compete in online programming competition to receive recognition and awards. You can network with leaders in this profession, especially in your local area within a specific technical interest. You can be mentored by professional engineers and technologists, and you can actually establish a professional profile highlighting your accomplishments. Like what has happened today, you can join and participate in discussion on various technical interests, and you can discover IEEE events and activities throughout the world. So the IEEE Zeta Rho chapter at the University of New Haven welcomes you to join our IEEE chapter. So that concludes today's webinar, and now you may disconnect. Thank you, everybody.
Bye, everybody.